Welcome back. And this time we're going to finish our discussion of the C# list. So we'll begin with a challenge. Start a new C# console project called list finishing. Create a method called test_list_string. Make sure it's callable from main. In that method, create a list of strings. Insert at least 5 strings into the list. Print the list. Remove a string by specifying its value, not its index. Print the string again, showing that you have removed an entry. Pause the video and complete the challenge. Welcome back. This is my solution to the challenge. A main method calls test_list_string. Test_list_string creates a new list of strings and populates it using the initializer syntax here. Prints the test list. This is a utility method. Just loops through the array of the list of strings and prints each one. Remove Felix and then print the list of strings again. I added Felix twice to emphasize that remove finds the first instance. It removes the first instance that it finds, but it doesn't remove all instances of it. Here we can see that Felix has been removed by specifying its value. The next challenge, in list finishing, create a public class student. Add the C# properties ID, first name and last name. Add a constructor that takes the 3 properties as parameters. Add a second constructor that just takes the ID as a parameter. Pause the video and complete the challenge. Here's my solution. I have a public class student with properties ID, first name, last name, and 2 constructors, one of which just takes the ID as a parameter, sets the ID, and one of which takes the ID, the first name, and the last name. Now for our next challenge, create a method called test_list_student. In that method, create a list of students. Insert at least 5 students into the list. Print the list and add a toString to the student. Remove a student by specifying its value, its ID, not its index. Print the list again, showing that you have removed an entry. Pause the video and complete the challenge. So here's my solution. See, I've created a list of students. I've used the initializer list syntax, and within that list I create new students. 5 of them. I print the student list, a utility method that I've added here that takes a list of students as parameter and uses the for each loop to loop through them. I had to modify student as hinted at before with a toString method. Here I'm using the C# string interpolation syntax with a $sign in front of the string, and then it looks for ID. It looks for identifiers within the curly brackets that are curly braces that are within here. So the ID, first name and last name will print, and I put a new line here so that it'll print vertically. Back to program. So then I remove list student by the ID 50, so it should remove Ging Freaks from the list. Let's run it. So I've printed the list. Kilo Zoldyck, Gone Freaks, Leorio Paladinite, Ging Freaks is here, and Biscuit Kruger is here. But after I remove the student, I haven't successfully removed the student. So I have a bug. So the next challenge is, what do I need to do to student or to remove to fix the bug? So let's test it again and see if I fixed my bug. And I have. So I removed student ID 50 from the list of students here with no change to this code here. So the bug must have been in student. I needed to override the equals method. Think about what remove does. It needs to go through the list and find an object that is equal to the object that I want to remove. Well, when I create new students here, 1, 2, 3, 4, 5 students, and I create a new student here, I've actually created a new object here. Well, the equals method that we've inherited from object falls back on reference comparison. So it's testing, do these objects refer to the exact same memory location? If not, that default implementation of equals says no, they're not equal. So we needed to implement the equals method in this code. And here, if you do this screwdriver, I think it appears as a different icon in some instances of Visual Studio. You'll see generate equals, and then you can modify it here. So for our purposes, for our business purposes, the only field that we're interested in is ID. It will then not look just at reference comparison. It'll look at the equals comparison and remove will remove the object when the ID is the same. That's our rule for how our object equality will work. So the need to override equals. Remember, all classes ultimately inherit from object. An object has default implementations of methods. It has several, but what's important for us right now is toString and equals. So the toString method just essentially prints the class name in C#. The plus EP is wrong here. That's Java. The equals method, though, just falls back to reference comparison. That is, are the two objects sharing the same memory location? That's not sufficient here because we create a new object in order to remove, be able to find the one that we want to remove. So the reference is not going to be equal. It's called a shallow comparison. So that's why we needed to override equals in order to get remove to work for us. Do you always need to override equals, the object's methods? No. Classes that are designed to be deep workers far away from the UI are less likely to need custom methods, either toString or equals. They're deep workers. They may be gathered in lists, but they're not sorted. They're not searched. They do work for us. Typically, the objects that go closer to the user interface are the ones where you need to concern yourself with overriding toString and equals. Here I am back, and I've corrected the case for toString and equals. See you in the next lecture.